So this is the fundamentals of sheet metal fabrication by you. I'll go ahead and say there's not a lot of presidents of manufacturing companies who are putting together fundamentals of XYZ. So this will be pretty cool here. So
Sure.
Take it away, man. I'll let you drive, and I'll click through it as you tell me to.
Yeah. Let me start with this. Maybe 10 years ago, a customer came to me and said, it was a really big customer who I probably shouldn't name. A name that everybody will recognize, a monolith in American manufacturing.
Right.
And they recognized that because they had outsourced so much knowledge, they had a real, what they call a brain drain at the time. And what it meant was their young incoming engineers just had a lack of knowledge that they weren't able to overcome. Right. What used to happen was young engineer comes in from University of Iowa with a mechanical engineering degree and wants to make a bracket, and goes but doesn't have any experience, and they would say they would go to the 50-year experience or 30-year guy in the model shop, and the guy in the model shop would say, you can't make it the way you designed it. That's nuts. What are you thinking? Right. And they'd have a dialogue, and the younger developing person would learn from the more senior person. Well, when they had cut out all the more senior people, they lost all that transfer of knowledge. And they admitted that. And so they said, we don't know what to do about this. And it's a real struggle for us. And so I offered it. So, well, why don't I come in? And they said, this is a fantastic idea. And I said, I can do just fundamentals, right? Metal fabrication. If you're sort of at a college course of sheet metal 101,
sure,
this would be a 1 hour to 2 hour version of that.
Sure.
And so that's where it started from, and I've done that since then at, I don't know, 6, 7, 8, 9 different places, and universally people, especially with engineers, that's primarily who I'm talking to. They're able to ask a lot of questions, and I try to ground this in real world applications, real world examples. So it's less theoretical, because you can go to the books, you can study various different things on. If you want to go to YouTube, you can find things there. If you want to do, your college, application, you can, in terms of knowledge, you can go and look at college courses and stuff like that. This is more sort of pragmatic, practical, experience based. And so that's the idea behind this. And then it just sort of runs through a variety of examples, and then lets the student, if you will, who's typically a customer, a potential customer,
right,
ask questions and say, well, what do you mean by this? And can you look at this application? And that turns into an opportunity for us to provide value that has some context. And if no business ever comes from that, so be it. That's fine. It's putting something hopefully useful out into the world.
Well, it's certainly valuable, right? To your point, this is one of the ultimate ways to bring value to our customer. So I think it's wonderful.
This is what I don't know, like 60 slides long. So if you want, we could take like 4 or 5 minutes and run through it pretty quickly. And
sure, you just tell me where to go, and we can jump through it.
Let's skip that. Yeah. So fundamentally, I would be saying, what are we doing here? I should go back up one. Go back if you can.
Yeah, sure.
So the second part of this, obviously we're talking about you typically in front of a customer, right? I'm saying, why does anybody care about design fundamentals?
Right.
Who's involved here? And then what are the processes around metal fabrication, and then some examples, right? That's basically the idea. So to start off with, we go ahead, what are we trying to do? Lower product costs, get rid of quality problems up front, so on.
Right.
And so the example I give on the next page is the customer. This is a real life example. A customer came to us, and this was an existing customer, and said, we are looking for improvement on this product. They were very, very good. There were a company that was involved in biometrics, and they were very good at what they did in the electronics and the cosmetics, and they had kind of lost what they had known about metal fabrication.
Sure.
With some engineering loss that they had. And they felt like this was an area they could make some improvements on this particular product. And it's got a bunch of wiring, ultimately the next level of assembly and so on. And they said, well, we think we can do maybe better here, but we don't have the mechanical engineering and mechanical assembly skills that we once had.
Sure.
And we said, oh, great. So we pulled our engineering team together, and we come up with 21 ideas in 3 hours And a very simple example, that white phenolic bracket that's up on the top there, we suggested, hey, you could change that to a metal fabricated bracket, get rid of the two white ones that are up on top, get rid of that 1.5 long piece of hardware. Those are $1.50 each. And you replace those with a couple of bends. There's 3 parts on the bottom. They've got 6 rivets in them. It was just fundamentals, right? It wasn't complicated, but it was what we do every day. That's the thing. It's what we do every day.
Right.
And we gave them 21 ideas. They couldn't use 5 of them because of design constraints. They could use 16, and because of the volume of the product, like, we're going to save $250,000 on this. This is amazing.
Sure.
And they're like, wow, you guys are stunning. I'm like, we just know what we do. This is our area of expertise.
Sure.
You know, the person who designed this, I'm 100% confident they had shares in hardware companies, because there's so much hardware in this stuff. It's like, it doesn't make any sense. But we know metal fab. We could apply that knowledge, and we went on our way. And that's the type of application impact that this can have when it's well done.
Right.
Let's keep going on. We'll skip through a bunch of these, because I think, for the sake of anybody who's watching this, they don't want to see, a lot of heavy text. Different examples. So I'll go back to one part. So this part, customer came to us and said, hey, again, we need help with design. We're designing the next generation of this. Can you guys contribute to the conversation? So I'd love to. Happy to do so. We're not designers, but again, design for manufacturability, that we can help with. So we took this product and we helped them design it. And go to the next page, 68% bigger, lower volume of parts, so 20% more product, actual part components, number of components, and we come up with the same cost.
Wow.
So a relatively, you complicated product, you got 30 or 40 components in here, and we're able to deliver, again, that design for manufacturability. And these parts are made without fixtures. These are all welded together because we poker yoked the parts and designed in a slot and a tab where these parts are intersecting with each other. We were able to get to no fixture costs and improve our welding and make sure there's more consistency in welding. So we designed the manufacturing process at the same time as the design of the actual part, the assembly itself.
Sure.
So let's go ahead from there. Different examples. Like we'll just go to the first line here, proper dimensioning. What impact does that have? You go to the next page. The next, I'm sorry, we'll go a couple more, because this just talks about that's who we are. We cover that. There's different industries we're in. This is what we're about. So this is our cultural component. Like, this is our production purpose. This is what we do as a business. The next one is our core values.
Sure. That's what you talked about.
Yep. And then again, some of the award stuff.
Right.
So we go to the you look at dimensioning schemes. If you go ahead one more, I think.
Tooling options.
Okay. So these are different. So this was the unfold. I think you go to the next page. There'll be a part here.
Yep.
Yeah. So I went to one of our engineers who does all of our programming, or the vast majority of them, some years ago, and I said, if you had to suggest to the engineers in the world that you interact with, what's one thing they could do that would make, as a broad statement, he sees these incoming designs from agriculture, construction, utilities, medical, musical, all these different areas, packaging, so on.
Right.
I said, if you had one suggestion for the engineers, what would it be? And he said, every single time you add a feature to a product, you click the unfold button. That's how it works. Because you will know immediately if you've created a problem. And if you did it every time, you would eliminate hours upon hours of the engineer's time trying to deconstruct the intent of the design. Sure. And so it was a time to market issue. And when we're doing a lot of parts, we do parts here, sometimes we're turning parts around in 3, 4, 5 days. And so you don't have a half a day's worth of work to lose on the upfront engineering. And so that was one, he said, you use the unfold every single time. This was also a part where
makes sense.
There was 685 dimensions on this print.
Oh my gosh.
And some of the ordinate dimensioning, and you got to question whether some of them really had value, when you could have said, refer to the SolidWorks to get the dimensions on this, because if you're making the part to the SolidWorks model, you're going to make it correct. You know, if you get the right unfolding and you get the right settings on your laser, if you're laser cutting parts, you're going to be right if you're doing it to the SolidWorks model. So that 685 dimensions, if you got to do a PPAP with that, you could be talking about spending 3 or 4 days just doing a PPAP.
Right.
And that's an enormous time impact.
Oh yeah.
So if you don't need it, then why do you have it on there? These are things to think about from the design intent.
Sure.
This was also a part that had we ended up having to remake this part completely from scratch, because on the page 7, I think it was, of the drawing,
There was
an issue with a silk screen, and the screen was actually called out incorrectly. We made the part per print, but the print was wrong, and that wasn't caught until the very last step, which was the silk screening, and they couldn't use it. We ended up having to completely remake the part at very high cost.
Right.
So all the detail, and the more detail you have on a print, sometimes you need it. Look, sometimes you have to have that detail on the print. But if it's extraneous detail, if you don't need it, sometimes the risk is you end up with clutter on a drawing,
Right.
and it actually subtracts from the intent of the design.
Of the actual, right. Yeah. That makes sense.
So let's go to the next. So again, that's application considerations. Do you have the right data points identified? How is it going to be measured? I mean, sometimes you get parts, and the orientation is such on the drawing, which is where you try to intention. If you don't know what the application is, and the drawing is all you have, you're going to try to kind of replicate the drawing view to do your dimensioning scheme as you're doing measurement.
Sure.
So if you don't need that, and if you can turn it where a part is laying flat and it gets a lot easier to measure, you can save a lot of time. It just depends on the application, though. Let's keep going on to the next. And this is a part of that came true. So this is a part where the 4 holes that are out in the outer area, you can see those are kind of slotted. They provide for a lot of movement, and the customer did a really great job of intentionally using the right reference points for the drawing on this, where they weren't tying those external dimensions to internal dimensions that had no bearing to each other. So it was actually really well-intentioned design on this one when the dimensioning was done.
Yeah.
Let's go to the next page. So then we get into some of the applications.
Right.
With lasers, and we're not going to do it here, but we spend a decent amount of time kind of going through why would you put something on a laser versus a turret? What are the design limitations? What are the what are behind the choices of different technologies we would use? And what you're seeing here, you've got a shuttle that's it's serving 2 different lasers, actually 2. We're typically in Amada shops. We've got Amada technology, so we've got 2 4 kilowatt CO2 lasers, and then last year we put in the 6 kilowatts, so 6,000 watt fiber laser. So the fiber laser it flies. I mean, it's amazing to watch it work. And both these are all automated. They can all run lights out. So, we walk out of here on Friday. We've got a second shift, so we're walking out of here, 10 o'clock Friday night. Turn the lights off. These things still run all weekend.
Sure.
Let's go to the next page. And so these are just different examples of turret designs. We don't need the detail on this. We're not doing stampings anymore, so it doesn't matter. And press brakes, some of the challenges. Go to the next page, and one of the examples we've given here is you got a hole near an edge. Well, when you're forming that part, what happens to the hole? The hole tends to stretch out if it's near the edge. And what do you do about that? You look for some different ideas about how can you design that hole differently. Is it going to have an impact on what you're trying to accomplish?
Sure. Is
there hardware near the edge that can be impacted by that hole stretching out? These are considerations you got to think about.
Right.
Using the same radius, if you're making a part that's got 4 different forms, if you're using 2 different radii on those forms, you're probably only going to end up having a more costly setup. If you do a consistent radius, meaning consistent tooling, and meaning the same tool for each hit, maybe you got a less costly setup, and it doesn't necessarily impact your design application. So So welding is an area that often has very high cost. It tends to be, not always, you can certainly automate welding, but a lot of time it's a manual process and it's time consuming, and it's critically important to the application of the product, but it can really be a cost driver. So we go to the next page. This is and it can have unintended consequences. So this is a customer who called us a number of years ago and said, it was a medical device. And you can see what's happening here. This bracket is being bent out of shape by the weld. So the customer called me up and they were pretty annoyed. They were local to us, and they were pretty unhappy because they were having to spend all this time cranking down on these nuts. This bolt here that they've got nut and bolt. And they were very, they were pretty annoyed because it was taking a lot longer to assemble these pretty intense mechanical assemblies for this medical cart.
Right.
And I said, well, yeah, can I, this is pre-COVID, right? So can I come see the issue? Can I come to your place and see what's going on? And so I took a picture when I got there, and I said, yeah, I mean, I can see what's happening. You've got the weld, it's right there. You've got an interference between the mounting bracket that's on that's holding you got the angle bracket is just that right angle that's welded to the tube, and then you've got this motor mount bracket
Sure.
that's being bolted to it. And I can see what's happening. You've got this big issue here, and I said, I'm really sorry that we did this. I didn't intend to, obviously. And well, we came back and we looked at the print, and the parts were the parts were made per print.
Right.
And what happened was, in the SolidWorks design, the weld bead was not accounted for.
Gotcha.
So it was just this right angle bracket put up against the tube, and the weld bead was not in there, was not laid in. So nobody in the design step observed that there was going to be this interference issue.
Gotcha.
And so we called the customer back and said, look, here's what's going on. This is both of these parts are perfectly per print. We had done the PPAP, so we're kind of confident it would be, but we still didn't like what's going on here. And they're like, oh no, this is terrible. Okay, we got to move the weld. Right, let's weld on the sides, let's weld on the bottom.
Right.
We're going to double up the welding because we're concerned about the strength issues. And I said, wait, hold on. So why don't we just notch the part? We just notch out the little motor mount bracket there.
Yeah.
So you give clearance to the weld. And they're like, oh, yeah, okay, that's a good idea. So sometimes you don't want to overthink the solution, right? And sometimes you just got to, what's the practical, observable, and that is zero cost impact then, zero impact on the strength of the bracket.
Right.
And it was a very simple solution to put in place.
Cool.
But the trick of it was nobody was observing from the assembly issue that the weld was going to be in there.
Right.
And that's something that we regularly see when you get to assembly levels, that the welding is often just unaccounted for.
Right.
Let's go to the next page. The next one again. So this is a part, again, we built this. This is basically a table, and it is 120 inches by 60 inches, roughly speaking. Okay. So it's a big part. We have zero fixturing, none, no fixturing at all. We weld the whole thing together. It's all aluminum welding.
Wow.
And the end parts look very similar to each other. We've designed them with the slot and tab, again, where one part is fitting in with the other part. And what that means is we have zero fixtures. We just pull the parts up against each other, make sure they're square, and we're off to the races with welding. So we eliminate fixture cost, and because of the way we design them, we can't swap the left hand and right hand parts. We can't swap either end out. So we've got fully designed into the process. And that was really about having a very open conversation with that customer about design requirements and then manufacturing requirements, and marrying those two things together.
Sure.
Let's go to the next page. So again, back to the hardware issues.
Right.
We can keep going from here. So again, one of the big parts with hardware, if we keep going, we can switch past these.
Okay.
And keep going. So there's different opportunities for different types of hardware is usually just about joining materials together. So sometimes you need to screw parts together, sometimes clip them together. It's just, these are all different ways that we can do that.
Right.
One of the key points with hardware, though, is we have seen far too many times over the years where somebody will find a piece of hardware that's kind of unique and interesting and think that's a good application, and it might be a good application, but if you can't get it for 6 weeks or 12 weeks, you were talking about supply chain issues earlier, this predates all of that. You use some sort of interesting, fabulous looking hardware, but you can't find it in stock anywhere. That's a huge issue. Or you might have a minimum buy. You want to make 25 parts or something, or even a first time run. You just want to test something out. You want to make 5 pieces, but you got to buy a minimum run of 1,000 pieces of hardware, and it takes 12 weeks.
Right. Well, I sent you something that looks like this today. We haven't talked about it, but I guess I'll go ahead and email my customer back and let them know that we'll be able to do something like this. I'm just kidding. I'm just kidding. We'll take it. I'm just kidding. We'll download offline and talk about that one.
Exactly. But the key part with hardware is that if you go to PEMNET, PEMNET, PEMNET.com, you can look up for Pen Engineering. You can look up their hardware inventory. So you
Wow.
can see if the hardware that you want to use is available or not. And
Will
if
you
it's
repeat
not,
that one more time? That
yeah, if you scroll up a handful of pages,
keep
up,
going.
up the other direction.
Oh, sorry.
It is one more, right there.
Right here. So this
Hemnet.com.
website.
Yep.
Okay.
Yep. So if you
Nice.
go to that, you can go and you can see what inventory is there. So, so if you go down to, we've got a couple more examples in it. I think we're gonna. So this is, yeah. So again, these are parts. Again, we talked about doing some quick turn product. These are parts that we turned around. Again, 36 components with 21 part numbers that we did in 3 weeks.
Sure.
Delivery. So it's kind of work that we do, and we did a lot of work. That was a hey, we got to make these right away. We then did a lot of work with that customer afterwards on improving the design.
Right.
So we can go down from there. Yeah. Let's keep going. Yeah, material reduction using nesting is a big deal. If you go to the next page, I think it's so we ended up helping a customer redesign this, and we're able to take some of the brackets
Okay.
that they designed out of 13 gauge. It was mating up with 14 gauge, and we said, let's design that bracket out of 14 gauge, put it inside of an open area on the sheet. So we're actually eliminating material costs completely. And we added gusseting to strengthen up that bracket.
Sure.
And so then we just put a couple of ribs in. That's no cost in the forming, a little bit of tooling cost. And we made a substantially stronger part with lower material cost.
Right.
It's a big deal, especially right now.
Yeah, absolutely.
Yeah, let's keep going. These are other just design ideas for material reductions.
Okay.
That really, again, giving a lot of strength into a part.
Right.
So you get a lot of plating information. Go down one more, I think. One of the best resources that you find, I think there's another page after this. This one here. So this is a bunch of different resources. Just an introduction to different types of finish that are available for metal fabrication.
Sure.
And just a summary of what they are and description. And yeah, this is one of those where the customer actually just got an email from customer today. We made some parts for them, and they emailed me right after and said they love the parts, they look fantastic, they fit fantastic, but they were concerned actually was about to look to cosmetics. And it said there's a little discoloration here. Although we're using a black chromate, which is a zinc finish, it's not going to be completely homogeneous. It's going to have a little bit of variation in it.
Right.
And so having those expectations and understanding when we can up front with a customer what those expectations. These are two different aluminum parts that will go together. All of a sudden, they don't look right together, but you're not going to guarantee. No plater I know, these are actually anodized, iridized.
Sure.
Nobody that I know is going to guarantee your finish on that.
Sure.
And
So with like the colors and stuff, right? So with paint,
yeah.
how does that work? Right. So let's, I want this color red, and then, Steve down the road wants this color red. How does that work for Laystrom, right? In terms of getting those colors.
So we have a supply chain partner, or one of our biggest suppliers, one of our key suppliers is the painter that we work with every day of the week. And so we have so much variation in a product that we do that it doesn't make sense to have an internal paint line.
Sure.
Because it'll be changing over all day long. So we go with a paint source. And that's one of the other things about being in Chicago. You can get anything you want, right? You can get any solution you want. So what we have with the guy who's 15 minutes away from us is they've got 3 or 4 paint lines. So they're constantly doing changeovers. That's part of their work. So with powder coat, and they're powder coated, you can specify the finish. And what you generally want to do is you can specify different Pantones or RAL numbers. And when we do that, ideally, the customer will have a paint chip, we will have a paint chip, and the supplier, the painter, will have a paint chip, and they're all the same. They're all produced at the same time, and will all be agreed on that being the match. And then you can look at the paint chip next to the part and make sure that they match each other and you can put parameters around what the lighting needs to be for that.
Right.
And you look at those together, and you'll be able to confirm by eye that that paint finish is what it should be.
Gotcha.
Now, plating, again, you're going to have more variability in the plating. With the painting, you're going to have consistency.
Sure, right, exactly. That's what was curious to me, because there's so many different colors that you get a Lowe's and you look around.
Is get paint chips, and with the paint chips, you'll eliminate that issue.
Gotcha.
Yeah. So again, lots of process alternatives, and the idea of this whole presentation is to have a dialogue with the people that you're engaging with, where you're talking about, how would you use a plastic edge protector? We saw that one part had a bunch of different plastic edges on it. Did it need it? In some places it did, in others it didn't, as it turned out. And so sometimes it's really about questioning, right? It's just about that, trust but verify kind of thing. Yes, I want to trust that you've designed this well, but let's have a conversation where we're verifying that you've taken all the things into account that you can take into account.
Right.
There's a few more examples, I think, of pictures of parts. So this is a part, the grain direction. The components had a different direction specified for grain than the door versus the frame.
Right.
The grain direction was specified differently.
Sure.
And that wasn't realized. And this is a cosmetic part. It looks beautiful. But until we got to the final assembly, nobody realized it was actually a different call out, because the development of the part was split out between different people. Mm-hmm. One engineer, so the one engineer was responsible for the total design, but it was a different engineer who drew up the door versus drew up the frame. They transposed the grain, and all of a sudden you've got something that doesn't match very well.
Cool.
So identifying something like that, again, this is a part where the weld, these are aluminum parts are welded in the corners, all four corners, but only two of them need to be ground. The other two don't need to be, because they're not visible. And so it's a very smart thing by the customer is like, hey, let me take this cost out of here. We don't need it. And as a customer, it wasn't our suggestion. They came to us this way. It was a clever idea. Like, just put the grinding where it's necessary. Don't put it where it's not necessary.
Right. That makes sense.
Yeah. Let's go to the next page. So this is the part where we made some homemade tooling for a whole bunch. You see that rib up on the top. You can kind of see it in that top aluminum component. That was some homemade tooling. The prior person that was doing that before us was doing 75 hits per part on the turret.
Okay.
And we ended up doing, 75 hits, and there were 6 different ribs. So I'm not fast enough to do the math on that. I'll let you figure it out later.
That's a Mark question. He's the math guy.
It's a lot of hits, is what it is, right? So I'm going to have to do it. That was 450 hits, whatever it is. Anyway, so the bottom line is we were able to do it with a press brake tool, do it in 6 hits.
Okay.
And then second application for these parts, if you go down to the next page, that whole front panel there was actually hardware. You can see go up one from there. That hardware is on the front panel of that assembly. The previous one with the
this bad boy.
No, before that same one there.
There we go.
The hardware that was on the front is actually really tricky, because that hardware needs to be put in after the screening is done.
Gotcha.
And it's that was a fun trick to figure out the right way of doing that without causing any cosmetic issues with those parts.
Gotcha.
We actually had it no quoted several times by suppliers because they felt like they couldn't do it.
Okay. Yeah, I do. I mean, it looks very complicated. I mean, there's a lot going on
There's
here.
a lot going on there.
Yeah.
The next 3 pictures all go together.
Okay.
And this is a product. You can see there's this heat-resistant foam and pressure-sensitive adhesive on here.
Okay.
The next 2 pages with the same product with the foam taken off and then just deconstructed into a flash and formed parts.
Gotcha.
And so this is a part where a customer came to us and said, hey, we want to see if you're interested in making these parts. You tell us, you can do these kinds of assemblies. And we'd love to take a look at these. And I said, great. Here are the specs, so on. And we took a look and we reviewed it internally. We pulled a team together. We went back to them and said, if we make this part, it'll be like $67.
Okay.
This was several years ago. But if you allow us to make some changes, we can significantly reduce that. And it wasn't actually $67, but I'm going to make that number up because it's going to go to a public place and no one else is going to be looking at it. But so we can call it $150 if we want. But
that's right.
We looked at it and said, hey, if you allow us to make a couple of changes, we can significantly reduce the price on this part. And so we collaborated together to reduce the price on this part. And so it was truly a collaboration with the customer, understanding what their needs were, their design intent, and able to reduce the part with using our supply chain knowledge as well as our old internal competencies.
Gotcha.
So it was a really fun project to work together on.
Cool.
No,
I say.
Different part again is a fun product where again it's hard to tell on here, but you can a little bit see that you got three parts that end up welding together. You got three parts stacked together here.
Right.
I've actually incorporated the weld bead into the inside. So the part that's sandwiched in between the two others, we actually put a relief in there, and we got the weld that's inside that relief.
Gotcha.
And so it vanishes once it's painted, completely disappears. It's a really fun design.
Yeah, you can kind of see how it's stacked together here right a little bit. Yep.
Yep.
Neat. So here's all the links right there.
Bunch of links, bunch of resources. One of the ones that there was one in the middle here called finishing.com. It's a fantastic resource. There's literally 50,000 questions and answers about finishing. Ideas, techniques, applications. I've gone down that rabbit hole a few times on there. It's really, really great website.
And of course, this is the main one, right? The Laystrom website. That's how we get in touch with you.
A little bit, but it's that's certainly something to go review. It's a little bit out of date because of all the changes and the speed of change that we've had in the last number of years. We need to do some updating in that.
Sure.
In that space, I'll add that to my list of things to do. And, we've started the update, we just haven't finished it. So
right.
But this is a presentation we give to many different applications. I can always be emailed, called, text, whatever. To see how we can help people figure out their challenges and find solutions.
Thanks everyone so much for watching the stream. It's Rob Brunson with Wallace Electronic Sales. We want to provide you and your company with quality and competitive solutions. We don't care if you're a small OEM, a medium-sized OEM, or a large OEM. We have solutions that we can provide to everybody. Feel free to drop me an email at rob.brunson@west-inc.com. Again, that's robbrunson@west-inc.com. You can also check out our full OEM line card on our website, and that's at west-inc.com. Again, that's at west-inc.com. Thanks so much again for watching the stream, and we look forward to talking to you soon.